So in this question, we have two equal charges of Q1 and Q2, and they're going to be separated by a distance r, and the repulsive force between the two charges has an initial magnitude of F. And if the magnitude of one of the charges is doubled and the distance remains unchanged, we want to know what is the magnitude of the force between the two charges. And so what we can do is we can make a picture for what's going on in this problem. And so right here, I'm going to put Q1, and then right here, I'm going to put Q2. And we're told that this force is going to be a repulsive force. And so that means that these charges, Q1 and Q2, they have the same magnitude and the same charge. So like if this Q1 is positive, it means that this Q2 over here must also be positive. And positive charges, those are going to repel. So there's going to be a force felt by this charge right here that will be pointing in this direction, and there will be a force for this particle over here that's going to point in this direction. These are two positive charges, and so they're going to repel like this. And if this charge right here was going to be a negative charge right here, so if this charge right there is going to be negative, then the force will be an attractive force. So this force would go this direction, and this force would go this direction. And it doesn't matter if it's going to be a repulsive force or an attractive force. The way we calculate it is going to be the same. And so the way we calculate this is going to be with this equation right here. It's going to be that the force will be equal to K, which is a constant, and then we have Q1, and then we have Q2, and we're going to divide all that by this R squared right here. And the Q1 represents the first charge, the number, and the Q2 represents the number for the second charge, and the R right here represents the distance between these two charges. So here's the distance between these two charges like this. And what we want to know is if we double one of the charges, like let's say we double this Q1 right here, so we'll do times 2 like this. If we double one of these charges, what's going to happen to this force right here? And so we know it's going to be repulsive force like this. And so what would happen is if we take this charge right here and it goes up by a factor of 2, what's going to happen is the force will also go up by a factor of 2. And so this repulsive force would be double. So if this represents the force right here, and this represents the force of this one going this other way, it will be double. So to show that, I can put a longer line like this to show that the force is now going to be doubled. You might think about, well, what would happen if we increase this R right here? This R right here is going to be the distance between the two charges. It's not the radius, it's the distance between the two different charges. And so what would happen if we double this, then this force right here would go down, but it wouldn't go down by the same amount that we double this, because this squared right here. So if this goes up by a factor of 2, then the force would go down by a factor of 4. And so the answer to this question is that the repulsive force would also go up by double the amount.